Hello, everyone. Hello and welcome. Today we're going to do another webinar, and we're going to talk about revolutionizing your data strategy and incorporating large language models and ChatGPT as a part of your technology landscape. So we're going to give people maybe a couple of minutes to join. And while we do that, please say hello in comments, say where you're joining from. I'm also going to share a few polls. So let's see. Tell us how familiar you are with large language models like GPT-3 or 4. Okay, we have folks who are very familiar. Excellent. Hello, Arun. Hello, Eric. Hey, folks, welcome. Now, how familiar are you with prompt engineering? Let's see. All right. And how familiar are you with the LangChain library? Awesome. We have some experts in the room. And lastly, share your thoughts on whether you think large language models will impact absolutely every industry out there. Yeah, I think people agree. Okay, with that, I think we can start. So a couple of housekeeping notes. I'll be sharing the deck at the end of the presentation, so you can make screenshots, but just know that you'll be able to download it. This session is being recorded, so when you're asking questions, you can put them in the chat, or you can invite yourself on stage and ask your question live. Just know that the session is recorded, and it will be distributed to everybody who's registered after. Okay. Now, okay, let's start. So this is what we're going to cover today. We're going to talk about large language models, what they are. We're going to cover the LangChain library. We'll talk a bit about knowledge graphs and using them with large language models. Then we're going to go into demos, and we're going to show a few cases how we used large language models with LangChain library. And then we'll try to take a guess at how large language models and AI will affect industries. And then we're going to share some resources, and there will be time for Q&A for sure at the end. Okay. So like I said, put all your questions in the chat, and I'm going to do my best to answer them. Okay. A little bit about me. I'm the CEO and founder of Infocratic. We're an end-to-end shop that provides services in analytics and data. So we do data strategy, we do data engineering, machine learning, all that kind of stuff. We're founded in 2020 with a mission to help companies get more value from their information faster. Initially, I started doing data strategy advice and executive coaching, and then later we expanded into delivery. We're serving clients in finance, advertising, media, logistics, and services. And we have over 30 experts in data, analytics, machine learning, data engineering, etc., etc. Okay, now a couple of words about what data strategy is before we start. This is how we define it. Data strategy articulates how data enables and inspires overarching business strategy. And we like a holistic approach to data strategy where we look at all these different elements. First and foremost, we look at the business, we look at data, at people components, at regulations applying to applied to a specific country, ethics, and also technology and security. So today, our focus is going to be technology. We're going to completely ignore all other parts of data strategy, and we're just going to look at a piece of technology called LLMs, large language models. So large language models are essentially very large neural nets that are trained on massive amounts of text and data, either using self-supervised or semi-supervised learning. Essentially, large language models, they can understand and generate natural language text. They also have memory. They can retain context. And this is specifically true for chatbots, chat-based LLMs. Okay. So this is what LLMs are good at. They're really good at understanding context and semantics. They're good at generating coherent text, translating languages, summarizing text, analyzing sentiment. They're good at extracting information out of text. They're good at transforming information, and in general, how they work, they predict text input. So these are just huge neural nets that, given an input text, they predict a sequence of words. Essentially, they predict what's the sequence of words that corresponds to that sequence would be. And it turns out that very efficiently mimics good amount of intelligence that's close to human intelligence. So what that means for businesses? Essentially, this means this: we have a large robot army. So I've been working with LLMs for the last 3-4 months very closely, and to me, my current metaphor for large language model is that they're like very knowledgeable, but also very opinionated and stubborn interns. So think of them like that. They can follow instructions, but you have to be really, really careful at crafting those instructions. And sometimes it takes many iterations to select the instructions for a large language model that would work for your particular case. But essentially, for businesses, this means that they have a large amount of they have scalable cognitive ability that's comparable with human. That means automation of a lot of intellectual labor out there. And that also means that natural language has become the de facto programming language. Okay. And there are a ton of use cases in anything and everything that you can think of where LLMs can be beneficial. We're going to cover a few today. Now, what are prompts? Prompt is essentially an input value you give to the LLM. Okay. And let's talk a bit about LangChain library. So LangChain is a library that provides abstractions over large language models that facilitate the use of them, right? So first and foremost, it provides a standard interface for interaction with different LLMs. You can use open source, closed source ones, but you have a single library, single class that allows you to interchange them. It also provides tools for managing prompts and also output parsers that can manage what you feed into LLMs and what like how you extract information after the LLM has processed the input. They also allow LLMs to interact with other tools and data sources, and this is very important because it allows to pair LLMs with other data sources that they have no access to, like databases, knowledge graphs, and things like that. LangChain allows creating chains of LLMs, essentially allowing you to pass an output from one LLM to another, and to create a very complex logic, to create very complex chains where you can have branching, where you can have all sorts of different logic. Essentially, you can create these mini agents that are good at something, and then you can chain them together. And agents. So agents are ways how you can wrap LLMs for you can use LLM-based logic, which is like non-deterministic, to decide on what actions to take. Essentially, you give a task to an agent and you give it a set of tools, and the agent performs manipulations on those tools. So you'll be able to see that today in today's demos. Now, knowledge graphs and LLMs, are they the future? So we talked about what LLMs are good at. Now let's talk about what things they're not good at, which is distinguishing between facts and fiction. Right? So LLM only relies on the data set it has been trained on. And it's there's the phenomenon called hallucination, where LLM generates something which sounds convincing, but is actually not true. right? So they're not really good determining what is true and what is not true. And of course, they cannot access any knowledge that's outside of their training data set. And this is where knowledge graphs come in. So knowledge graphs are essentially graph structures, graph data structures, or can be like databases and all sorts of different graph technologies, where nodes, they represent certain facts, and well, these are all facts, and they're connected with relationships, right? So there's no structure, but there is a ton of useful information in a knowledge graph, and you can make a large language model interact with a knowledge graph in very productive ways to make it source information that it doesn't have, or to check whether a fact is true or not. For instance, if you're researching a set of companies, you can keep all the factual information that's tested and verified in a knowledge graph, and then make the large language model agent refer to that knowledge graph when it has to, when it needs to. So this is a diagram about LangChain agents. So LangChain agent, it uses it can use large language models as a logic, basically as a decision maker, right? So it's using the reasoning ability that large language models possess, but then it can use other sources. It can use Google or social media, or it can use other data sources that you have, like documents you feed it, or databases, or knowledge graphs, and it can decide when to use each source. And you can give it fairly complex tasks that we'll show today, and it will go and perform those tasks. Okay. Now we're moving on to our showcase. Let me just ask if you have any questions so far. I see a question from Arun. For a business keen on seeing results immediately and not wanting to wait for a long time due to investment reasons, what's the best route forward? It really depends on the business, right? This technology is very quickly commoditizing. I think a lot of the costs, they lie on the hosting large language models, but there are quite a few reputable providers, like Azure, for instance, that can host your large language model, and then you can be relatively you can be relatively safe when it comes to some proprietary data. I think the biggest risk is when you're using non-reputable providers of LLMs, that your data, essentially the data that you feed to it, will leak out of the organization. So lots of organizations that they have chosen to self-host their own instances of LLMs, but that's a bit costly. You need quite a bit of compute power, and there, for smaller companies, you have to go with SaaS-based LLM hosting, and for larger companies, they can afford to host their own instances for sure. Okay, but like it really depends on the business and on the business side. Like just watch the demos and see if you can get any ideas of how to use LLMs. We already helped 3 companies with and we were using LangChain, and you guys decide if you find these examples useful or inspiring. Okay, so these are our use cases today. So one is analyzing customer interactions, essentially a log between customers and support agents. The other task was researching companies in a certain space, and replacing a team that would do manual research with a research bot. And then also we had a case of building a Semantium knowledge graph using large language models. Okay, so for today's demo, there's no data from from any of the customers. We have replaced it all with dummy data, obviously, and we have also simplified the demos down to the very bare minimum, so that you guys can see the actual kind of the most important, the principal parts that we're relying on LLMs, but we stripped a lot of complexity and a lot of kind of fine tuning that was done in production use cases. Okay. Now let me switch to my browser. You guys can still see my screen, right? Okay, our first case is analyzing call logs, and we're going to use Colab notebooks for all of these demos. And I'm going to walk you through these notebooks as we execute them. So first, we're just installing the required modules, which are LangChain and OpenAI, required for OpenAI API. Then we're going to import all the modules that we need. I actually had to drop. Hold on, just give me a sec. I needed to drop the examples of conversations here into this folder. Here we go. Okay. Now, to use OpenAI API, we will also need their API keys. And I'm going to destroy this key after the presentation, and it has quote on it, so don't use this key. Now we're loading our text file with conversations, and this is the kicker. Okay, so we're creating a prompt for our large language model. It says you have to analyze the conversation with the customer support listed below, and then this is just a placeholder for a specific conversation. And then we tell it, after analyzing the conversation, please output the following: conversation duration in the following format: average agent response time, customer lead sentiment, agent sentiment, customer user ID if it can be identified, customer lead email if it can be identified, their name, shipment ID, agent name, was customer satisfied or not, did customer abruptly terminate the conversation, is there any follow-up action required? Okay, and then we ask it to output the results as a JSON structure. So let's run this prompt. This is an output parser, and this is, I was just going to show you how you can convert results from free-form text that comes out of the LLM and into a Python class Python structure. So this is our parser. Here we're creating an instance of the OpenAI chat LLM, and we're also creating a chain that is going to use this LLM and our prompt that we created here. And we're all set. So let's look at what kind of conversations we have as an input. So if we look at the first conversation, for instance, this is, hi, I seem to have lost access to my account. Can you assist me? I'm sorry to hear that. So you can see like a typical support log. Okay. And now let's analyze it. Okay, so we pass this as an input to the LLM. So what it gets is essentially this prompt where this conversation placeholder is replaced with this text. Okay, and this is what we got. So it figured the conversation duration, it figured the agent average response time, customer sentiment grateful, agent sentiment helpful. It didn't get customer user ID, but it got their email and name. Customer satisfied, true. Customer left, false. Follow-up actions, there are none. Let's try a few more. If we run it on another conversation, see what that is. Okay. Customer sentiment frustrated, agent sentiment apologetic, user ID. Yeah, so we can play with these different conversations, but you see that just with this simple, essentially this is our programming, right? A few years ago, this was unthinkable. We used to do sentiment analysis for many companies, and it used to take a lot, like natural language processing used to be much harder, and you had to use more sophistication in order to achieve these results. Here, it's possible to do with just a simple prompt and a few lines of code. and you can point this to your chat or call transcripts and get a ton of useful information. So you can feed this into other logic that can, for instance, there's a shipment ID here and the agent needs to follow up with the customers once the shipment is located and delivered. So you can create all sorts of, let's say, a backlog of important actions. You can decide whether this conversation needs to be reviewed or escalated. You can analyze the performance of your agents. You can find who are the most kind of disgruntled customers. And a ton of information can be extracted just from bare text of input. Okay, so this is one example. The next example is a research agent. And this is a case where a company needed to do research on a whole bunch of companies. They already had a list of companies, tens of thousands of them, and they hired initially a team that was doing manual research over web. But then LangChain came in, and essentially what the team was doing was replaced with a robot that can do the same thing much faster and much cheaper. Okay, again, we install these libraries. We will need Serper API, which is a wrapper around Google search, setting out our environment variables. I know if we need to suppress some warnings. Now, again, we create a chat LLM, and now we create also a tool that is, we give it like it's a useful tool when you need to ask with search. Okay. And we say specifically you need this to find out intermediate answers in your task. We're also giving it a memory so that it can retain the memory of the chat, which essentially just accumulates all the messages that you pass to the chatbot. And here we're creating our agent chain. So this is not just this is not a chain. This is more an agent that has tools. You give it tools. You give it a large language model. You specify the agent type. This is just for it to output some information for us, and also we specify the memory. Now, this is our prompt. You are a research bot that has to gather information about companies. For this task, you will be researching top 3 S&P companies. You first have to identify which those companies are, and then you have to find out the following information about them: company name, headquarters address, revenue, number of employees, name of the CEO. And also, I want you to output this the results as a JSON structure. Okay. Let's run this prompt. And now we run the agent and the magic starts. Right, so typically how this works, this is an observation that the agent has about its work. So it says, okay, please provide the list of top 3 companies you would like me to research. And then it does some Google search about this. Not sure why we're not getting the further output. Oh, did it already? I think it didn't out. It wasn't that articulate about its thoughts, but here's the output basically. So it found out what the top 3 S&P companies are. It researched all of this information. It used the Google search for putting it all together, and it output results as JSON structure. So we did this in a bit more sophisticated way in a production environment, but essentially we used an agent that would determine what information is missing from the web, what other facts it has to research, how many attempts at researching that facts, like it was given a limited amount of Google searches it can do to find out a specific fact, and then putting all those facts into a database. Okay. And of course, there was some orchestration to see which companies the robot has researched, which it hasn't. Okay, and the next case that I wanted to show you, this is a bit lengthier, but here we'll be constructing a knowledge graph from scratch. We'll be using our Semantium knowledge graph for that. And we'll be constructing a knowledge graph from scratch using large language models. Okay, so this is an empty instance of Semantium. And this is a knowledge platform that we built for managing semantics in organizations. So this wildcard search means that return everything, and it doesn't have anything at the moment. just to show you that we have an empty graph. Okay, now we're going to run this. Again, install packages. We're going to set the API key. We're going to import the required modules. This initial step is just preparation and some initialization. We're going to use GraphQL to access the knowledge graph, and we also have a database which is a standard Northwind database that Microsoft uses a lot in their demos. So for simplicity, we decided to stick with it. So we're also creating a connection to the database. And here we're going to define some wrapper functions around GraphQL and around SQL. So these allow us looking up nodes in the knowledge graph, connecting them, creating nodes, and we also have some SQL wrapper functions that return metadata from the database. Okay, yeah, and we don't call this as it empties the graph. Okay, now the fun starts. So first we're going to teach it about the modeling paradigm that we use in Semantium, where every single atomic piece of information is called a quant. And we have a limited number of classes for those quants, and we also have a limited number of relationships between those quants, between the pieces of information. So here's our prompt. You are a clever algorithm that can parse a description of a business to extract the entities and relationships between them and use those entities and relationships to help construct a semantic knowledge graph. Each entity you extract will represent an atomic unit of information that is called a quant. Quants are connected to other quants in predictable ways called relationships to record facts about the business. After extracting entities, you have to classify each quant as a member of one of the following classes, and then we'll list all the different classes that help us later on to deal with semantics. So this is like very, very, very high level semantics for the quants. The entity class properties can only contain one of the following classes described above and nothing else. Stick to the list provided in the dictionary, and don't add any more values to the entity class. If you can't reliably determine the class, classify it as a concept. Use singular for entities unless they're a given name. And you also have to map the relationships using one of the following. So these are relationship types. And we want the output in a JSON format like this. And we also list step-by-step instructions. So it took us probably a couple of dozen iterations to come up with this prompt that reliably worked on free text. And we're also giving it an example of the output. So we're telling it this is what we want you to output. Okay, now let's create our prompts. We're going to package these prompts into a chat prompt object. And this is our business description, right? Where we have just a few sentences that describe our Northwind Traders business, which is a fictitious organization. So this is our business description. Now we're going to create a chain that will use this to extract our entities and relationships from this. Okay, so this demonstrates that given a natural language description, you can actually extract meaningful units of information, and you can extract relationships between them. Okay, so let's see what it comes up with. It should output something that looks like this. So a list of triples. In knowledge graph, triple is an object, the predicate, and the subject. So one entity, the relationship between it, and the second entity. Okay, still running. Okay, maybe give it a minute. Yeah, so feel free to put any questions in the chat. We're going to address them all at the end, and I still have a few slides that I want to share. So after this demo, we're going to jump to the slides. Come on. Okay, these are our triples. So it's, for instance, identified the entity orders, that it's a concept, and it also somehow identified shipped by as an organization. And so it identified Northwind as an organization, Northwind Traders. Now, if we go look, so first we had to insert this information into our graph. So we will run our wrapper functions that will now create these quants, create these pieces of information, and they will also create the relationships between them. I'm not sure why is this is running so slow. Maybe this is because of the Demio video sharing that I'm using. Things look way slower today than they typically are. Okay, so if we go and we look at our graph right now, we will see this quants appearing. Let me refresh this. Yeah, so we're starting to see some entities that are also connected. Okay, and I think because how slow things run, I might have to kind of cut this short a bit. Or maybe we'll trim it down a bit as we go. So our next step is going to be ingesting metadata and sample instance data from a SQL database. So how Semantium Knowledge Graph works, we have 3 levels. The first level is semantics, which is a purely abstract level where we have abstract description of a business. And the next level is metadata, which is physical metadata tied to a specific data store. And the third level down is instance data, which are actual data values like master data, reference data, etc., etc. Okay. Now, our next step in this demo is to ingest some metadata and sample data, also some sample instance data from an actual database. We're going to use this Northwind example by Microsoft, but we're not going to ingest all the tables and columns because it's going to take ages, especially with my notebooks running so slow today. Before we ingest that, we're going to create a couple of special quants that are called database table and database column. So these are just concept quants on a metadata level. These are going to determine that our other quants are either database table or database column. Next, we're going to use tables, but let's stick just to customers table. I'll trim this down so that we finish today. Okay, so we're just going to use the table customers. And now we're going to go through these tables and we're going to create quants that connect both the metadata and instance data. Okay, so we're just ingesting some data from this database, and let me show you how this looks in the graph. Refresh. Yeah, so the quants colored in green, this is the semantic layer, okay? So let me zoom in like this. This is the semantic layer. This is the abstract definition of our business. And the quants that are in dark blue, these are this is the metadata level, and this is instance data. So these are examples of data. Let's see how much it got so far. Yeah, so it's continuing to bring some metadata and instance data from the database. I might have to interrupt this just because of how slow things are today. Yeah, let's interrupt this so that we finish on time. Now, next, the magic happens, right? So we're going to map the semantic model to metadata and instance data. And we're going to use LLMs for that. We're going to first load all the semantic quants into a list like this that we feed to the model. Then we're going to give it a mapper prompt that says the following: you are a smart agent that can determine the connection between database object metadata and nodes from a knowledge graph containing language and semantics. As an input, you will be given some metadata describing a database object, and you will also be given a list of semantic quants representing nodes in semantic graph. So we give it step-by-step instructions. Again, not to spend too much time on this. We can later on review in the recording, but with this, we're instructing it how to connect semantic quants and metadata quants. Now we're going to get all our metadata quants, and we're going to iterate over the metadata quants running our logic at the same time, right? So we're going to use this chain here. So this is what the chain gets as an input. It gets database object name customers. It's a database table. And here it actually found that the semantic node has a quant customers, which directly describes the database object name customers. Therefore, this node is returned as the output. And now you're going to see here that connections are starting to appear between our metadata layer and metadata level and semantic level. Okay, here. So for instance, in link customers and customers here. And as it goes further, it might find something else to link. Okay, so let's see if it's still working or is done. Let's see if it found out anything else. Yeah, mainly it just found customers. But here you can see, this is just a very bare bones example, but you can see how we can use large language models to construct a knowledge graph completely from scratch, right? We gave it a textual business description, we gave it a database, and we relied on LLMs to ingest that data into a knowledge graph and to map the information. Okay. Eric asks, will we have access to the demo and the slides after? So the demo notebooks, I haven't planned on sharing, but reach out to me on LinkedIn and we'll figure something out. But you'll have the recording for sure, and the slides will be shared at the end. Okay, one more question. Once the knowledge graph is populated, how does the LLM know what facts to use? Excellent question, Tyler. So you'll have to use search over knowledge graph. So what you do, you typically provide it with a tool that can look up your nodes in a knowledge graph, or it can do a proximity search. So it can look up a node, and it can look up what are the nodes that are, let's say, 1 level or 2 levels away from it. And so you'll be creating some wrappers for the knowledge graph for that, and you'll be giving it to the agent, to the large language model as a tool. So you instruct it in the prompt explicitly. Let's say when you come up, when you come across a company name, you always have to look up information about that company from a knowledge graph. So use a knowledge graph lookup tool whenever you see a company name and get additional facts about this company. Okay, the same can be done for customers. Let's say if you're working with customer data, you can ask it to look up customer data from the database whenever it sees a customer email or customer ID. Okay, again, it will all be in the prompts. The magic is in the tools. So a tool is essentially a function that your LLM knows how to call. So LangChain allows LLMs to take the results of that function call. So first, it allows them to know about being able to call these functions, and also being able to accept the output of these functions as an input into the kind of next prompt into the LLM chain. Okay. All right, so let's go back to the slides. Yeah, so with these demos, you saw how we can apply it in real life. There's a ton of cognitive power in these large language models, but like I said, they're like very knowledgeable, but also very stubborn and opinionated interns. Now, how large language models will transform industries? Obviously, there's a ton of automation coming. And right now, we're essentially in the 4th industrial revolution, which is automating the cognitive tasks. So a lot of office work will be automated. And it also will take customer understanding to the next level. I think we'll see a revolutionary advancement in marketing. I have my next slide on this. And also sales and customer service, because you'll be able to hyper target and hyper focus on your customers. Automating fraud detection and prevention, procuring information for investments, for trading. Productivity will be enhanced in pretty much every area. And It will also be much easier to attain a data-centric paradigm. Those of you who follow me know that I'm a big evangelist of a data-centric approach. I'll share some information closer to the end on that. Essentially, this is creating a single data model for the organization. So there will be a lot of automation in data management facilitated by large language models. And this is a slide I borrowed from Scott Brinker. He talks a lot about marketing, and here he talks about kind of first order effects and second order effects of large language models and generative AI. Right. So, for instance, if when AI generates content, zero order effect content is easier, faster, and cheaper to create and can be created by more people. First order effects are the quantity of content will grow exponentially. The personalized content will be generated in context, and our spam will grow exponentially. And the second order effects are buyers will further shout out all sorts of push marketing and sales content, even if hyper personalized. They will trust few trusted sources, and buyers will pool content with their own agents. So they will use AI agents for consumption instead of relying on various push channels. So for when AI generates code, our software will be more and more commoditized, so it will be easier, faster, and cheaper to build. And a lot more people will be able to build software. The quantity of software will grow exponentially, and I'm predicting also that quality will go down drastically. And a lot of on-demand software will be able to be built. Now, as software becomes more disposable, it's easier. It will become disposable, meaning it will be easier to just recreate a piece of software than to maintain it. And I predict there will be sort of like dynamically generated software that can tailor itself to kind of on-demand needs of the organization. So there will be a next generation agility in software engineering. And as software becomes more ambient, we will think less about apps and we will think more about experiences. And this very well resonates with the data-centric approach that we're that we're evangelizing. Now, there will be also lots of forgotten zombie apps. I fully agree with this. Now, as AI absorbs content and data to answer questions, asking an AI agent is the easiest, fastest way to answer questions. I think lots of you today use ChatGPT or services like Find or ChatPDF or all of these sorts of services. Now, traditional search engines are going to be displaced, or they're going to transform, and the long tail of content will become widely accessible. Now, data becomes a first-class marketing channel. Essentially, feeding data to these AI bots will become a first-class marketing channel. And as AI execute tasks autonomously, this is the automation we've been talking about. A lot of digital busy work can be automated. The quantity of automation will grow exponentially, and there will be massive boost to productivity in lots of areas. Okay, and API services become first-class marketing channel. Bot commerce grows, and big ops, orchestration and governance, I can see them kind of exploding exponential as well. Okay, so this is a very interesting analysis, trying to think a few steps ahead of what will happen in the industries as LLMs get adopted pretty much anywhere. Any of you attended the latest Build conference by Microsoft by raise of hand? Did you see that everything was around LLMs and kind of LLM-based AI? Same as Google's last conference. Now, these are some resources to get you started in the space. This is the LangChain library documentation, probably your most important source. Andrew Ng's Deep Learning AI, they have a couple of really good short courses on prompt engineering and LangChain. I highly recommend taking these. There's also the prompt engineering guide online. There's the official blog, YouTube channel, and this is an interesting app that created a user interface for LangChain. So for people who are not super familiar with Python coding, for instance. with that, I say thank you for attending today, and please put your questions in the chat. I'm happy to answer any questions on the topic. Okay, so did I answer all the questions? No more questions left. All right, let me see. Just close my chat. 1 second. All right. So if no questions, let me just share the deck with you guys. Okay, please feel free to download it, and you will find links to our calendar endpoint if you'd like to book a call and chat with us in more depth about these topics. Please connect with me and Infocratic on LinkedIn, and also go to datacentricexecutive.com and put your email there, because there's an awesome course that's coming out very soon. I'm about 80-90% done with it. And it's going to talk a lot about the concept of data centricity and putting information first in your business. Okay, let me check the chat again, see if there are any questions. With the knowledge graph, if you get sufficient size there, how would you proceed to build your own model? So Tyler, can you be a bit more specific regarding the question? Is this the size of the knowledge graph you mean? So it will be dependent on the knowledge graph technology you use, right? Whether it's responsive enough. And when it comes to semantics, you will have to chunk it, right? So newer, larger models, they allow larger input. So they have much larger context size, if you will. You'll be able to use much more text. I think GPT 3.5 is something like 4,000 tokens, and GPT-4 is 32,000 tokens, but there are already models that allow like 100,000 tokens. And this allows you to put quite a bit of information there, but a very standard technique is just to use chunking and divide that into smaller pieces. So let's say if your semantic layer cannot fit in 4,000 tokens or 32,000 tokens, you would just divide it into chunks and feed it to it chunk by chunk. Okay. Any other questions, folks? All right. Thank you so much for attending today. There's another question. If it was really large, would you use a vector DB index? Yes, that's a separate kind of big topic, using vector databases and vector DB indexes to essentially, so you're switching to kind of working with embeddings instead of using kind of just text. But like we haven't covered that today, and honestly, I haven't used it in real life just yet. I've used chunking for scalability, but I'm aware of vector DBs, and I've seen how folks use them, but I haven't personally used them. All right. Anything else? Thank you so much for attending today. Again, connect with me on LinkedIn. Come to our future events. If you subscribe to our Infocratic page on LinkedIn, or you follow me, you'll get notifications when we're hosting. We're trying to do at least one interesting talk every month, and show you guys something related to extracting value from information faster. Thank you so much, and have a great rest of the day wherever you are. Bye.